Welcome back to Made Up of Wires. It's been a while. Into a very special Friday stream. Normally I don't stream on Fridays. I take that day off, but I unexpectedly didn't stream for most of the week. So here we are, back again. Good to be back. I haven't been working on Symphony of the Night much offline, but I did mention earlier in the week Metro Wrap, and I'm wrapping up the final changes for that. It seems to be almost 50% faster, or running 50% of the time that MWCC gap does. And I'll tell you a little bit why in a second. But if you want to know more about the Symphony of the Night decompilation project, you can go to soten.z.dev to learn more, and you'll see links to GitHub, where we have all the things that we've decompiled so far, links to Discord as well. I may finally be getting close to getting over my sheltered preference and get back on Discord. Sometimes I disengage and it's hard for me to get back in, but we'll go back in. No issues with anybody in the community. Just it takes a toll on me personally to be involved in a group. So anyway, let's get back to what I was talking about earlier. So last week I mentioned Metro Wrap. I thought this was kind of fun and cool, so this will be the logo, at least at the start, for this project. But what Metro Wrap is a wrapper around the MetroWorks compiler. So the MetroWorks compiler was written for command line Windows, and that's what was used to compile the PSP version of Symphony of the Night. So we have to call that Windows version. There are several things that MetroWorks doesn't support, including, but not limited to, the include ASM and include RO data macros that we use. We can't, so on the GCC side, what we do is basically just include those files, and they act like any other include would, where that code gets injected in line. MetroWorks doesn't support that same thing, so some funny business is done where the original C file is compiled with some placeholders. Then each of the assembly files is compiled separately, and then those two things are merged together. So previously, and what's currently, if you go to GitHub now, what you'll see is a tool called MWCC Gap. There are a few concerns I had with that. One being the lack of dependency file support, and I'll go into that in a little bit. And the second being just the performance. I'm not a big fan of Python for things that are called hundreds or thousands of times, and you'll see why in a second. So, yeah, I've been spending most of my time there. I think my implementation is probably good enough for an alpha. At the moment, there's still a lot of debug stuff in there. But I mentioned performance, and so this is, I've been trying to narrow down where I can improve things, where things need to maybe be replaced. And so this is one entire invocation of Metro Wrap and all the programs it calls. So Metro Wrap itself doesn't do much. It's mostly a coordinator and kind of transformation layer for the source code that comes in. Allegrex, the Allegrex assembler, is what's doing most of the work. Weibo, which is a very minimal, you can think of it as Wine, but extremely minimal. Wine is what calls MWCC Gap, or sorry, MWCC. PSP AS is something that's used because the MetroWorks compiler output isn't necessarily compatible with Allegrex, and so it just does some cleanup on that. I've been considering, and after I release this, I may talk to the the rest of the Soten decomp team and see if that's something that should be just integrated directly into MetroWrap, especially if a Legrex or another GNU assembler is being called. We'll see how that goes. But you can see most of the time, this is the only time that MetroWrap spends any time doing anything. The rest is primarily the tools that it calls. And the total aggregate time right now is right around 10 seconds for the roughly 900 C files that we need to compile for the PSP, all of them going through MetroWrap as part of that compilation process. So when we were using MWCC gap, the time for those 900 files was around 19 seconds, and now we're down to 10 seconds. And there's two primary things that are contributors to that time. Really the most significant thing, and where my disdain for Python comes, is 7 of the 9 seconds saved is just Python runtime. So just by converting it to Rust, there's about a 40% reduction in the total time just by translating it to a new language. That's, I think, unfortunate, but when Python is in the hot path, you're going to have slow things. Hey, Scribble Lurker, good to have you. And so that's what this time here, where it says MW, all of the time being spent, basically this MW section would be about as long as all of the other sections combined if this was running in Python instead of Rust. The second major contributor, and this took things down by another about 2 seconds, or around 10% of the total time. MetroWrap only calls MWCC once. In the optimal case, MWCC gap will call it once, and that's when there are no include ASM macros in the file. If there are include ASM macros in the file, MWCC gap will call into the MetroWorks compiler twice. We'll run it twice. MetroWrap doesn't do that. The reason MWCC gap calls it twice is to differentiate compiled symbols, or symbols that are in C, from the symbols that are in the assembly files. Unless there's something I don't know, which definitely could be. I don't know what I don't know necessarily. We have all of the metadata from the C file itself to determine whether or not a symbol is coming from C or assembly, and we don't need to use the elf file to figure that out. So anyway, I cut out the second call in the include ASM case, and that helps reduce time as well. So yeah, I think that first version is probably wrapping up. There's one more thing that I want to do, and I'll touch on that briefly. When we compile, we get errors like this, and oops, sorry about that. Those errors right now are no different between MWCC gap and MetroWrap. And what my plan is, and I have the code, I just don't have it filtering through yet, is to replace these. This is a DOS file path with its backwards slashes. Replace those with a Unix file path. And in this case, MetroWorks requires a C file. It can't take things from standard input, and so we write a temporary file to be able to compile that, rewriting these paths as well to reflect the actual input source. That's just kind of a quality of life thing. It doesn't do much beyond that, but sometimes these are complicated, and you need to try to figure out where something's coming from. Anyway. So that's that MetroWrap update. When we left, we were getting close to one of the larger files. not quite there yet. We're going to try to clean this up and finish it on the PlayStation side. We really only have something around this section that needs to be fixed, it looks like. A little bit more at the bottom. And slightly more on the PSP side, but we'll start here around line 470. Hey, Aldrich. So all the familiars are decompiled. There's one function in the sword familiar that I think isn't done. And I agree. So and I'm going to say this for the audience, not for you, because I'm sure you know this already. When you load weapons, there's a different address space for the left-hand weapon versus the right-hand weapon. And they actually compiled all of the files. It's the same C file, but they've compiled it twice. Once with the left-hand address space and once with the right-hand address space. It might be interesting, actually, to look at how the Xbox 360 does that, and if they got around that in any way. So I think we might have to have like a Familiar 1 and Familiar 2 address space, but I think that could actually be really fun. Yeah, let's think about it. All right, so getting back to this, we're going to start around line 470. Probably get a... Oh, I didn't get a human ding. That's good. So the first thing I see right off the bat is we're missing a variable somewhere that may be the root cause of our problems with this matching. Maybe not. But I'm going to go down here and see if we can see anything obvious in this section that is also not matching. There's a bunch of register issues and things like that above, but part of that is going to be finding the variable that's missing, and part of it may be related to whatever's going on in this section as well. So right off the bat, there's nothing particularly strange. We get some register issues down at 484. This particular expression, there are no variables here. Often the S variables are used to, they're mapped specifically to certain variables, but in this case, they're not. So we can't try to tweak anything based on that. So the place that I'm going to be investigating basically is all the way through to the end of this section. So if we get past 511 or so, it's likely a problem that needs to be fixed some other way. So more register issues, 499. Again, that's not something that we're controlling directly. S0 is our entity register. So there's not really much that can be done with that. We have our function call. Same register issues here. So unfortunately, we're getting to the end and I haven't found anything very specific. Oh, this one is actually somewhat interesting. Oh, I'm guessing these are the same thing, and it just has to do with the stack being different. I was hoping something slightly more obvious would have come out of that, but yeah, it's just a stack issue. So, nothing too obvious there. So, unfortunately, I think oh, I bet. I have not even looked. So MIPS assembly, I was reasonably familiar with before getting into this, and it's not something that I was too afraid of. I looked at the SH2 assembly, and I don't know. Do I even want to? I guess I have to eventually, but it seems awful. It's just different. It's a very different instruction set from what I'm used to. So I'm gonna go down. I think we did this on Monday, but I'm gonna do it again. Just going through and looking at these registers and seeing if I can associate them with variables. The other thing that might be worth doing is going the opposite way from the variable to the from the variable to the register. That may be more helpful. Sometimes in these longer functions, though, the variable allocation gets messed up as the function goes on. So this is S1, and it looks like both the game version and our version agree. Entity is going to be a little harder because I think it's gonna change throughout. Okay, yeah, I can see that. And are you, as you're doing that, are you also trying to preserve the size of that function? So Aldrich is saying is making sure the right registers are being preserved. And there's usually like ABI rules for like caller saved versus callee saved registers. So what registers do you, when you're calling a function, for example, what registers do you expect to not be the same as after you called the function? And which ones do you expect to have your data in them? What Eldridge is doing is slightly different, though, is my guess, is trying to modify code within a function, and the rules there are pretty arbitrary. You just mess with what you want. Oh, so are you doing jumps or jump and links? If you're doing jump and links, then there are rules for that. S0 is entity. I'm gonna move this up. Probably won't affect anything, but usually that entity pointer is the first variable. Pause X. So this is, I should go back and look at all the entity use cases, but pause X and pause Y may be where things get interesting, and we can find some other cases where those registers were being used. So actually we both have S5, which is nice. So what I'm going to do for pause X is highlight S5 in both. And what I want to see is, are these used the same way everywhere? And down here they are. So I'm just looking for that highlighted register. And this is a long function, so... Oh yeah, I'm sure there is a lot. So I remember you mentioning that you were going through, here's S5 here on 419. You were going through and trying to find all of the unused area. Did you finish that project? Like going through with 100? Yes, you succeeded. Very good. There is virtually no dynamic memory allocation. I don't think there is any dynamic memory allocation in the game itself, but there might be in the SDK. Okay, so here we do see a difference with register S5 to 78. So this is not something that we control. Oh. Do I have this right? That'd be interesting if... Yeah, that looks right. So yeah, unfortunately it's not something we control, so keep going. What I'm looking for is something that's both wrong and directly controllable. S5 here is being used the same way. Interesting that it's also in a facing left section. I'm not completely familiar with how MetroWorks makes its decisions, so why that works sometimes and doesn't. All right, so that's that. Pause Y, we're gonna look for. And we do have an earlier use of this, so it should be. Oh, this may be it. So this is looks like possibly a different variable. So this is S2. I'm going to add a new variable here. I'm going to call it offset Y because I don't have a better name for it. What I want to see is, so this pause Y, I know I have pause Y down way at the bottom. And I want to see if that's the same or not. Oh, S2, it is the same, unfortunately. Drat. I still will try another variable there. Strange that it's S2. So we use this a couple different times. Okay, so what I want to see is whether S2 and S4 are always used the same way. Same as before. I'm going to start at the top though. 78. Not something we control. 103. That's something we control. 158 is the first time I think that it is something. Oh, let's look at this. 134. Why aren't those highlighted? Because it's backwards. Yes, so this may be a different variable. Okay, so let's try that. So that didn't seem to work out quite like I had hoped. We do have a more correct stack at the moment. And we'll and let's see if that helps. PlayStation all, yeah, it did. PlayStation liked it. Missing a NOP. Register issues. So it's probably still not quite right. Okay, so we're gonna keep going. Keep going on the side. So at least now we have the correct stack size. And so we might have to shuffle register use around. I'm going to start on 101. Make sure that I have that right. This was S2. And do it again. Make sure that it's always being used the same way. So here we have a case where it's not. 108. I like it when I don't have to focus. So this part is so detail oriented. So this looks like offset Y is getting subtracted here, maybe? It seems reasonable. And we were rewarded. These look the same, but we're missing something here on 150. Don't control it. Drat. Okay. The greater than equal is potentially an issue. These are nice whole numbers, and normally I wouldn't change a whole number, but it might be worth doing. I'm going to leave it for now and hope that it's correct. Still looking for that S2 and S4 difference. And we have some on 233. And always hoping that it's some register that's controllable. And here we're on the switch, so we don't control it anymore. Just slow and methodical, that's what we need to be. When I find one that does look relevant, I will call it out, but I have not seen anything yet. 555. So this is the first one that I've seen. So this pause Y, I don't think is actually... No, it is used. And unfortunately, this, if I switch this to offset Y, it's going to break everything else that I just did. We're going to lose our stack. And so unfortunately, this is more correct, it looks like. Having that pause Y variable was the correct choice. So basically I need to back out not everything. So we're going to replace carefully offset Y, pause Y. I don't think that there's going to be any issue with this. I think what we discovered not necessarily was that this was a different variable. But that one calculation was being reassigned to the variable. I think that was what we how we won in this case. Okay, so that should compile. A little worse off because the stack is still wrong. So still searching for the missing stack variable. Let's go side to player. Now that should be S4. And same thing. Is it used the same way everywhere? Can we go quickly or not? I don't know. So here we have a different variable. So this may be it. Let's change this one to facing left. Is this what we've been looking for? Maybe. So again, not perfect, but better. Worse on the PlayStation. PlayStation regression. And let's go to 59. Let's look at that one again. This may not be a variable after all, though. Let's look at S6 and see if that's used throughout. Ugh. This may be something. 374. It's not directly related, but no. Never mind. Okay, so we're looking for S6 registers. Are they used? So far, S6 seems to align perfectly. So I'm going to assume S6 is correct. I don't know if that's actually the case, but it looks like it. And our last one is temp v1. It's not used till the very end. And I'm not confident in this. So let's do this. I'm gonna change it so that it's a plus. That didn't make a difference. 82, AV29. Good to be back. Good to have you back. Well, so this seems to be S3, and besides this move that's happening up here, that variable seems to be correct. Okay, so we have a few other things that we could go through, and some of them I'm not excited about going through. Sometimes register or the variable declaration order changes things. That's the worst. So we can try putting these in some order related to their variable. Sometimes they're in the reverse order that you would expect. That doesn't make sense to me here. Sometimes it doesn't make a difference at all. And when it makes a difference and when it doesn't make a difference is not something that I really understand. In this case, it doesn't seem like it's making any difference. So I'm going to put them in a logical order rather than a random order. The other thing is this temp v1. How do we progress? Well, when this function is done, what I'm going to do is take it over and put it into a C file, and it's actually kind of a fun thing. I'll go over since I'm not making much progress at the moment. We'll transition into this. So the basically this is a Ship of Theseus decompilation. We have a C file that exists that gets generated from the game source. And in that C file, we have these include ASM macros. And when the compiler comes in, that can be machine code that's extracted directly from the game disk that we don't have to touch. And so we know that it's correct. It'll get compiled in, and those bytes for that code will be correct. As we're working and we figure out what C code is going to compile to those same bytes, we replace the include ASM with real C code like this one here, and then compile it again, and it still should produce the same binary. And so then when that's done, after so much work is done, we'll go through and it'll get merged into GitHub, and on GitHub and on the main project page, we can track the progress then of how many of those assembly importing macros still exist versus not, and there's a pretty comprehensive list then of all of the overlays that we've worked on, as well as the ones that we haven't worked on. Does that answer the question? So little by little, function by function. This one is, usually functions don't take several days. Usually you can get several functions done in a day, and there's a lot of duplicate code and a lot of other things like that. This one just happens to be something eluding me as I'm going through this. Yeah, well, we're working hard. It's a hobby. Sometimes hobbies are harder than not. I'm going to go back through. There's a couple things that I'm going to look at as I'm going through. I'm going to look again what the differences are, and if I can tell anything about either what additional or missing instructions might mean. One of the things, and I'm hoping it's not this, but it could be, is how comparison operators work. When we think, is something less than 4 or less than equal to 3, logically those mean the same thing. When you're writing a compiler, though, you're writing a compiler and you're looking at those two expressions, and you may branch off to different code that treats those expressions slightly differently based on whatever rules the compiler authors were coming up with. And maybe they should generate the same code, but there's two different implementations, and then they diverged in some way that doesn't change their equivalence or how the program's going to run, but does change the code that gets generated. I make a face at that because that's what it seems like happens with greater than versus less than equals operators in MetroWorks. Sometimes, in this case, they're generating the same. Sometimes, though, it affects code at a distance. And so if I said this is greater than or equal to 6,000 in hex, that would be the same as saying greater than 5FFFF in hex. Locally, that will produce the same code. But one of the things that it did, let's back that out. For completely unrelated lines, like down here, changing that changed all the registers that are being used. And it didn't actually significantly affect the registers here that are being used. it affected them mostly elsewhere. So how do you find the right expression when changing one area affects something far away? Unfortunately, the best way I know is to brute force, which is a bummer. And so let's kind of think about this in a straightforward way. I really don't think, when you have nice whole numbers, it's really unlikely that they would replace it with something that's not a whole number, especially when the representation is actually something more like this, some decimal value. So that could be, but I'm skeptical. We still have the right number of registers. I really think it's a register or variable issue at this point. But like I said, I'm going to go through and just kind of call out what these things are along the way that are different, and maybe something will pop out as I'm looking at it. So here we have a register issue. When S registers are being used, there's a chance that relates to some particular variable. You're assigning or reading or writing to a variable. In this case, that's not what's happening. And so those registers are just being used as intermediate storage for that expression. For A and V registers, it's even less likely that has to do directly with variables. If there were other issues here, like offsets, which would show up as immediate differences, I might think that maybe some of these expressions were written slightly differently, but I don't think that's the case there. What I think I'm mostly interested in is the moves, the additional moves. Could be that some of these are the wrong data type, or that the order of some of these expressions is wrong. But I'm not seeing anything obvious there either. When there's a variable involved, it makes it a little easier. So here we do have one though. We have this S3. So it's possible that this is being pulled out. Let's see what our S3 is. Just a pointer. And I think it's unlikely that this is a pointer, so we're not dereferencing it. And it's our code that has the register, not the original, the S register. So continuing on. 43, same thing. And again, this is happening around an expression that could be written slightly different. But again, this breaks a whole bunch of registers later on, so I don't think that's the case. There are things, though, where maybe it's not just one, maybe it's many that are acting that way, and you'd have to change them all to get the effect that you want. That's not ideal, but that may be what happens. There might be other things too, like this being a plus equals of a negative value. It's not quite. Let's. And so how does that affect? Doesn't change anything. Hey, Otter. The goal is to get a matching C function that produces the same assembly as what was on the Symphony of the Night disk. This is one of the functions in the Grant, Ralph, and Sifa boss fight. And so it's mostly there. It's 97.84% the same. And what that last 1.16%, or sorry, 2.16% is a mystery that I'm trying to solve. Let's look at this 243. Gross. There's a lot of code that gets generated when you write a switch. There's two different ways that switches can be generated. One as a series of if-elses, which is what's being done here. The other is as a jump table. A jump table's possibly more optimal. You read from a fixed offset in memory, and then you can jump directly to the area of code, whereas this one you have to do basically evaluate every possibility and then jump to that particular area of code. So yeah, I may, because this is boring, I like to do the boring stuff offline, I may switch to something else since I'm not really making progress on this. This is the first time we see a move introduced down at 271 here. So a move is just copying the data from one register to another. It could indicate that we're putting this sound effect into a variable, and then that variable is being moved into the register. But I think that's unlikely. This is usually the way those function calls are written, with the variable inline. And what I think has happened is whatever has diverged probably has already happened, and now various registers are in a different state as to their allocation, and so we can't trust much of anything anymore, and something before this has already caused us to diverge. So whatever it was, I probably missed. I agree. So you always talk about registers in terms of their numbers, and I need to have the table with me to translate your elite speak. I think that's the same as A0. Register 4. I did have one up actually last time we were talking about this. I don't think I have it up anymore though. Oh yeah, right, like I close any tabs. Here it is. Yes. A0 is register 4. I think of their, like, in MIPS you have 32 general purpose registers. Register 0 you can't write to, well, you probably can write to it, but it's always the value 0. You'd be writing to something that you can't read back from. And there are, the last 4 registers are used by the CPU for various things, so it'd be kind of stupid to use them for other purposes. And then the remaining 32 minus 5, 27 registers can be used basically for whatever you want. And they have conventions, and so for most systems, probably all systems, that the ABI or binary interface says register 4, 5, 6, and 7 are used for function arguments. And then how those registers are used, I mentioned caller saved versus callee saved earlier. Basically, that's kind of the contract between functions if you're writing directly in assembly, like how you can use those registers and if you need to restore them before returning or not. And so I think of them that way, like register 4 is register A0. So 4, 5, 6, and 7, those are used for arguments. 2 and 3 are used for return values. Their V0 and V1 is what they're otherwise called. And then there's the S registers, which are often used by compilers for variables, and those, so that's 16 through 23. Those need to be saved. And restored by the called function. There's the T registers, 8 through 15. Those need to be preserved by the caller if you need them. So S2, the variable that we have assigned with S2 is pos y. Totally unlikely. I'm going to put it in there just to see what happens, but I don't think that that's going to... definitely not a register called pos, or a variable called pos y for the variable. One thing I didn't think of, actually, and might be worth... yeah, we do get some movement, some change in register, but I don't think that's what's going on. One thing that may be occurring, and I didn't even think about it, is... no, that's not what's going to happen. I was going to say that there often can be static data or variables that exist that we don't have yet, and introducing a static function, for example, the compiler then can look at those two functions and kind of coordinate and determine if in the static function, if I avoid using these registers, then I don't have to preserve them when I call in this other function. So sometimes that has an effect as well. But in this case, there's no related static function that we know of so far. I think I'm going to pause work on this. We have something called the decomp permuter, and we could put this in. Actually, it might be worth looking at this GCC version one more time, and just seeing if there's anything obvious here. Yeah, ordering of these just does not... The way that this is constructed in general is strange, but it matches relatively closely how it's done on another function. Yeah, I think I'm going to come back and deal with this another day. Maybe, like I said, maybe run it through the permuter. So let's go and look at what else we have. We do have other things in this file that we can look at. Create explosion puff is, I think, misnamed because it's very close to that function, but not the same. So let's do something easy, make some progress. Actually, I don't even know if I have time for that anymore. I spent too much time on that other thing. So we're going to create some new scratches and come back to that other one. So I'm going to look for the create explosion puff. This in a shared header. This may be the same, it may not be. Looking at this, it does look very similar. probably is the same. Assuming that entity ID is the same. So we're going to take it and see if that's the case. Not the case. Oh, because I didn't choose the right preset. There's a lot of variables that go into getting a match. We have a preset for Symphony of the Night that makes it easy. Any of these compiler options, any of these compilers, you have to try to figure out which combination of all those may be correct. And this actually was an identical function. I don't know if it's correct. If this actually is the explosion puff. But we have enough information to put the C in, and this will kind of illustrate the point I was making earlier, where we can replace these include ASM lines with equivalent functions. Let's see if we have explosion puff already. I don't think we do. Yeah, so we have unknown 28 is what we have. What's strange about this is it's not near the explosion. If it is create explosion puff, it's not near another function that uses it. But let's look to see possibly another function here uses it. We'll do that two ways. We'll look at the C code as well as the assembly. So this is the only reference, so this may just be dead code. And if it's dead code, we might not even have an equivalent in the PSP. So that worked as well, and we have one less function there. Let's see if we can get another one quickly. Try this. I've not vetted any of these. I don't know what they are. They could be hard, they could be easy. If they're hard, I might not be able to continue on. Make sure we select the preset. Sorry, I missed your comment. Eldritch said the K registers are redheaded stepchildren. This is a little longer than I want to do right now. But let's get it cleaned up and then we'll call it a day. So we get rid of all the function signatures that M2C couldn't figure out. We have a... Oh, I forget what this is called. Animate entity frame, and I won't have that in my context because I have not done that yet. Now that we know what that is, I'm going to put this in the context. These other ones, this probably is a init. Yes. M2C tries to figure out what the types are for all these things, and sometimes it's right and sometimes it's wrong. All right, let's use that. Try again. See if this is any closer. M2C is the decompiler that we use as this starting point. What I'm looking for here is warnings, or sorry, errors. I don't care about warnings at this point. I just want to get this to compile. What's happening here probably is this is a primitive, I think, RS1. Yes, it is a primitive. And sometimes as an optimization, instead of copying one byte at a time, either the compiler or the developers choose to do a 32-bit copy, and they do that by casting. So let's fix those. And we need to look at what the offsets are of each of those fields. And we'll get that from primitive.h. So we want unknown 28. Yeah, so it looks like it's just all three colors being copied at once. And it's being copied from offset 1C, which is R2. So we have the load word macro to deal with that. Offset hex 10 is R1. And this one is R0. And so we get something compiled. Have to remake some of those other changes. So it looks like case 1. Nope, case 1's fine. This is a fall through, so this is fine as well. So that is correct. And I think block 60 is probably gone as well. So we have got rid of all the go-tos, and I think this is probably more correct than it was in terms of the arrangement of that code. So we're at, like I said, about 77% similar. 10,000 something differences. I don't know what the unit of that number is, just that I need to get it lower. Now there are not other args to this function. Some interesting register choices here. So A0 often gets moved into the S0 register. That's not uncommon. Unfortunately, I don't think that I'm going to be able to make much more progress here today, so we'll come back to this on Monday, and we'll talk a little bit more. So I mentioned on Monday, and I will mention it again. So I think my personal big news is that Metro Rap is working. It's building all of the PSP version on my system. I still need to go and try to get this integrated with everybody else. And what that means is we can compile the PSP version in about half the time that it took with MWCC gap. And even better, if I touch a file, touching means modifying a file, say Armor Lord, that's fine. And make Metro Rep emits a dependency file, and we'll make sure that that gets correctly rebuilt wherever it is. And I'll show how that works. The Armor Lord. Let's say I make a mistake in this file. I'm just going to put some garbage here and make. We'll export the version specifically for PSP EU. When I make this, we see that error happened with MWCC gap. The build system would not know that file changed and wouldn't know that it needed to recompile another file. So lots of fun stuff. That's all I got. I didn't even show you. It was on the wrong screen. Anyway, trust me, it works. Go to soten.z.dev and I'll see y'all tomorrow. Nope, Monday.